Hello guys, welcome to another tutorial. Um, Today we shall be considering an aspect of information retrieval, and that aspect is called page rank algorithm. Page rank algorithm. So as our usual tutorial is to illustrate with an example and to explain some of the concepts around page rank algorithm. Now, this is the example we'll be using to explain the page rank algorithm. Now, here is a graph. This is the graph, and this is the analysis, the calculation of the page rank algorithm. Let's look at this first as an introduction to page rank algorithm. This is used in ranking web pages for returns. And when you go into a particular web page and you need to rank the web pages, you can use the page rank algorithm to calculate the order in which the web pages will be listed. Alright, so it ranks pages just by authority. Now, you see it does not attempt to capture the distinction between hubs and authority. Now, what do we mean by hubs and what do we mean by authority? It's as the English word is, when you have, for example, an airport, okay, or you have an assembly point, or a garage, a bus garage or car garage. That is an hub. That is where people gather together, or where something come together. So that is an hub. Now, so in page ranking, web page ranking, and hub is a page that is pointing to another page, and hub is a page that is pointing to another page. While an authority, a page is referred to as an authority when it is being pointed to by many pages. So I want us to understand that. I'll write that down. It's a bit tricky, but we need to get the difference. So in page rank algorithm, a hub, so a page, a web page is referred to a hub, when it is pointing to another page. But in authority, a web page is referred to as an authority. When it is being pointed to. When it is being pointed to. by a hub. So when it is being pointed to by a hub, so you refer that page as an authority. So we need to get that very clear. It's very important to understand the difference between a hub and an authority. So for emphasis, a hub, a web page is referred to a hub when it is pointing to another page. Basically, it is pointing to another page called the authority, and authority is a web page is referred to as an authority when it is being pointed to by hub. So we need to understand that's the concept behind the page rank algorithm. So what is this saying, just as a preliminary for us to understand? So it rank pages just by authority. Okay, it rank pages just by authority, those that are being pointed to. We're going to see that shortly, and apply to the entire web graph rather than a local neighborhood. And the endorsement that forms the basis for the page rank measure of importance is that a page is important if it is cited by another page. So that's what it means when a page is being referred to by another page. It is that page is referred to as an authority. Page is referred to as authority when it is being pointed to or is being cited, as is being used there, when it's being cited by other important pages. So that means that page is an authority, is endorsed. Alright. So the idea behind page rank is you measure the in degree, that is the number of the pages that are pointing to that page. Okay, just measure in degree doesn't account for the authority of the source of the link. Page rank starts with a simple voting based on in links, and this is very important, as we shall see shortly in the example. The nodes repeatedly pass endorsement across the outgoing links with the weight of a node's endorsement based on the current estimate of its page rank. So this is a form of iteration. We're going to see that when we go through the example. Okay, and the weight of a node's endorsement, we will also see that. So more important nodes make stronger endorsement. So for example, looking at this now, this is an authority. This is an authority because it is being pointed to. These arrows are pointing into it. Okay, this is an authority, and at the same time it's also a hub because it's pointing to others. So a web page can be both an authority and at the same time a hub. So a page that is not being pointed to, a page that is not being pointed to at all is not an authority. So if you have a page that is not having any in degree arrow, then that page is not an authority, but it could be a hub. A page that is not pointing to anything, that is not pointing to any page, that is not having an out degree, cannot be a hub. Cannot be a hub. It can be an authority, but it cannot be a hub. I hope you understand that. But at the same time, a page can be what? An authority, and at the same time a hub. We need to get that clear. Now, we get that clear. You also see that this page, each of these box represents a web page which has a weight attached to it. So this is 0.1 attached to it. So this is just like a session. So if we start from here, now this page is pointing to two other pages. So it divides its endorsement equally between the number of pages that it is pointing to. So because its weight is 0.1, So it gives this one an endorsement of 0.05 and this one an endorsement of 0.05. So it's a fair sharing. Likewise, this page is pointing to 3 other pages, and you can see that it is distributing its weight equally, sharing its weight equally on the pages that it is pointing to, this, and this. As you can see, the 3 arrows that are coming from here. Now, here, this particular page is deriving its weight, this 0.08, from the endorsements that are coming. So it has two, it's being pointed to by 2 pages, these 2 arrows. So its weight is 0.05 and that of this 0.03. That's what gives it 0.08. I hope you understand that. So this is an authority, okay, and its authority is dependent on the weight, the endorsement. It's just like writing recommendations or liking, giving a likes on social media, on Facebook. The number of likes that a particular thing or person or product is receiving is an indication of the number of endorsement for that particular person or that page. Okay, it's just like also in voting in elections. The number of votes, the higher the number of votes casted for a particular candidate determines the influence or possibility of the candidate emerging as the leader or as the winner. So that's the same concept here. So you see this page has 0.08 because of the endorsement that it received. You also see here that this page has 0.08 weight because of the endorsement from here, 0.5 and 0.3. And you will see that this page only have a weight of 0.03 because it has only one endorsement. So if you check these 3 pages and you want to check which one has the least authority, so this is the one that has the least authority because it is being given the lowest endorsement. I hope you understand that. So we'll go back now to example. So we want to get the page rank values over the first 2 updates, that is the first 2 iterations. Alright, so we need to calculate the page rank value for A, B, D, E, F, C, F, G. Remember, each of these is like a web page, like a website on the web, on the internet. Okay, so just like a web page. So we want to cast to determine the value, the weight of each of these. So what does the page rank algorithm say? So this is the algorithm. The algorithm says you have to follow a set of iterate rank flowing process until convergence, that is until you see that the values are not changing anymore. So you have to continue to iterate this. In a subsequent tutorial, I will show us how to make use of Excel spreadsheet to do this, but we just see a simple example in this case. So we want to iterate over this. You need to iterate until it converges, that is until the values that we have here, when you continue these steps, until these values remains relatively the same, that is nothing is changing. So at that time you know that you have reached a stable state. So you let S be the set of pages. So like I said, these are our pages. So S be the set. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So our S is 8. I hope we get that. So our S is 8. So initially you will see that R of A, that is the rank of A, where A is a member of the pages. Okay, where A is a member of the set. So the rank of a page, of a particular page, initially is equal to 1 over s. That is the 1 over modulus of s, the total number of pages in that our graph that we are considering. So which is 1 over n for all of the pages that are part of the set of pages, the graph that we are considering. So in this case, we are going to initialize each of these to what? So this, the rank of A initially will be 1 over 8, the rank of B is 1 over 8, rank of D is 1 over 8, rank of E is 1 over 8, and so on and so forth. We get it. So there's no partiality initially. We give them all the same ranking. Alright? So it's just like students coming into being enrolled into the school. All of them have the same GPA, initially when they start, but as they continue in their studies, then their GPA begin to vary based on their performance. Okay, that's the same thing that's happening. So we give them all the same rating. Okay, so now until ranks do not change, okay, that is, we see that the ranks are not changing, that means it has converged. That is the values that we get. So for each of the page that is member of S, we use this calculation. And what this calculation is for the rank of a particular page will be the summation of the rank of each of the page that are pointing to A. That is why we talk about is authority. That's why when we said the other time that it rank pages just by authority. Okay, so we look at, you see that this arrow is pointing from B to A. That is, you want to calculate the rank of A, you need to know the pages that are giving endorsement to A, the pages that are pointing to A, that are giving endorsement to A. Alright, so it's just like I said earlier, in election, if you want to know who is the winner of an election, you calculate what? The number of endorsement, number of those who voted for the person. So that is the same concept here. So for us to calculate the rank of a page, we look at the rank of each of the pages that pointed to A, then divided by the out degree of that page. The out degree is just like I said here, the out degree of this particular page is 2, because it is distributing its endorsement for 2 other pages. You see that there are 2 arrows coming out from here. While the out degree of this one is what? Is 3, because it's distributing its weights on 3 pages. I hope we understand that. It's very, very important to get this concept right. So let's say back here now. Without understanding, it should be easy for us to solve our problem. So initially, that initial step is not showed here. The initial step is not showed here. But you know that the initial ranking of A is 1 over 8, B is 1 over 8, C is 1 over 8, D is 1 over 8, E is 1 over 8, up to H. So each of them is 1 over 8. So let's see how the first step now looks. So for us to now calculate the rank of A in the first step, we use this formula. So let's look at it together. So the rank of A, now I want to calculate the rank of A. So for me to calculate the rank of A, let's look at it together now. We need to know how many pages, what are the pages that are giving endorsement to A. I need to know the pages that are giving endorsement to page A. Alright, So let's look at the pages that are given endorsement to page A. So to calculate the rank of A of page A, so let's look at the pages that are given endorsement. So it's been endorsed by, or it's being pointed to by. So let's look at the set of the pages that are pointing to A. So let's see that. So if we go to our graph, then we see the pages that are pointing to A. So if you check here, you need to be very careful here to make sure that you get it right. So I'm just trying to be sure and do it properly. Okay, so let's look here. Right, so if we check here, you will see that A is being endorsed. A is being endorsed by, what are the arrows that are pointing to our A? Can we see that? So A has an arrow from D, so we include D. A has an arrow from E, so we include E. A has an arrow into it from H, we include H. A has an arrow into it from F, so we include F. A has an arrow from it from G, so we include G. That's very, very important to understand those that are coming in. So based on our formula, we can calculate the rank of page A. We can calculate the rank of page A now, since we know those that are endorsing it. So let's now look and calculate the rank of page A based on our formula. So the rank of our page A, so rank of A will be equals to the rank of D, the first one. What is the rank of D? 1/8. Don't forget we said initially 1/8. That is the rank of D. Alright, so this is for D. Divided by, don't forget our formula, the out degree divided by the out degree. So we divide, okay, divided by the out degree of D. So what is the out degree of D? So we see that D is distributing its weight on two things, that is A and H. So the out degree of D is 2. So divided by 2. Okay, so that is that for D. So we sum, we go to that of E. So what is the rank of E? The rank of E is 1/8 divided by, what is the out degree of E? You see that E is distributing its weight on H and A, so it has 2 arrows, so that is 2. Alright, so plus the next is H. So we look at, what is the rank of H? 1/8 divided by, what is the out degree of H? The out degree of H is what? Is pointing out to only just 1. So you see that that is just 1. So that's just 1/8. So plus F. What's the rank of F? That is 1/8 divided by, what is the out degree of F? You see that F is pointing to just 1 one page, that is 1. So that's just 1 plus the rank of G. What's the rank of G? 1/8 divided by, what is the out degree of G? You see that G is just pointing to just one person, just has one out arrow, one arrow pointing out. So that is 1. So that's 1. So the rank of A, by the time you do this calculation, then you get 1/2. You can do the calculation yourself. You get 1/2 because this will give you 1/16 plus 1/16, and this is plus 1/8, 3/8. So by the time you do it, you are going to get 1/2. So that is how you come about this 1/2 here. I hope it is clear. So the same thing goes for the other ones. The same thing goes for the other one. You just repeat the same process and you can be sure that you get this correctly. It's very simple. It's just a way of calculating the rank of pages. Alright, so for B, you do the same thing. You want to know the pages that are pointing to B. So what are the pages that are pointing to B? You will see here that the only page pointing to B is A. So then what you do is you calculate the rank of B by saying what is the rank of A. Don't forget, initially the rank of A is 1/8, and that's where you might mix it up. You are not going to use this rank for this one. You are going to use the initial rank in here. So the rank of B will be 1/8 divided by, so you check the out degree. This is a rank of what is pointing over out degree of A. So what is the out degree of A? You will discover that A is pointing to where? A is pointing to 2 places. Okay, A is pointing to B and C. So the out degree of B will be rank of A, which is 1/8 over out of A, which is 2. And so 1/8 divided by 2, that's how you get 1/16. I hope it's clear. You need to take time to work it out and be sure you understand it. Let me do that H, which is 1/8. So the rank of H will be, we check in the graph the pages that are pointing to H. So how many pages are pointing to H? You can see here this and this, so D and E. So it will be the summation of the rank of D and E. And so the rank of D initially, remember again, you are not going to use this 1/16. You will use the initial one, which is 1/8. So it will be 1/8 divided by the out degree of D. So D is pointing to 2. So that is 1/8 divided by, that is 1/16. Then you look at this E, you also be 1/8, and E is pointing out to what? To 2. As you can see, there is 1/16. Okay, so it will be 1/16 plus 1/16, and that will give you 2/16, which is 1/8. That's how we have 1/8 here for H. I hope it's clear. By the time you get to the second iteration, the rank of A here, we still come back here. The rank of A is those that are pointing to A, which you have listed earlier. Those pages that are pointing to A, don't forget the pages D, E, H, F, G. But instead of using 1/8, 1/8, 1/8, no, we will not be using 1/8 again. We will now use the updated rank here. You will understand that. We will now use the updated rank here. So to calculate for step 2, we use the values in step 1. To calculate for step 1, we use the initial value, which are all the same. So I hope that is clear. It's very subtle. You need to practice it to be able to get that very well. So you use for calculating for step 2 now. Okay, so you need to use the rank of D, which is 1 over 16 here, divided by 2, E 1 over 16, H 1 over 8, F 1 over 16, and G 1 over 16. So let's just do this a simple one, this B, which is 1 over 4. So you look here that to calculate the rank of B, how many things are pointing to B? So it's being endorsed by only A. Alright? So B is being endorsed by only A. So you look at the rank of A divided by the half degree of A. What is the half degree of A? So A is distributing its stuff on what? On 2. So then the rank of A is half. We are going to use this half to calculate this. And it is dividing its rank, its weight on 2. So that is half divided by 2. That is why we have 1 over 4 here. I hope it is clear. So that's the way it goes. Thank you for listening. Please, if you like the tutorial, can you please give us a like, and if you don't like it, give us a dislike. You can put a comment. All this will help us to improve on our subsequent tutorials. Thank you very much, and